And hey, forensics fans. So, Dr. Galuski here, and as promised, we're going to go over the assignment or worksheet, whatever. Is it for a grade? No. It is a way of beginning to think about things and looking at stuff. And yes, when you have our final exam, you might see some of these calculation type things. They're very basic, but it is part of crime scene investigation. And that is how we can begin analyzing maggots and using them as a potential time of death measurement. And we're looking at the paper from the Forensics Teacher, Spring 2014, and we're on page 26 is what I'm looking at, which is the facts and hints. This is going through some of the basic definitions about how we can take and the weather information and develop the degree day, that is the accumulated degree day and the degree day in Celsius, centigrade. We're going to use 10 degrees as the base temperature in this case. And this is just a way of developing sort of a fudge factor number that is going to be an indication of how cold or warm the period of time has been, and that of course influences the rate of development of the insects. So in the lab here, when we raise fruit flies, we raise them at a constant temperature of 85 degrees, and so that's kind of like the optimum temperature for them, and that makes them develop at about their fastest rate. Too much fast, or too fast. If you raise the temperature up a little bit too high, they actually don't do as well. And if you bring it down too low or bring it down colder, they just take a lot longer. And so sometimes around here, we may not have our incubator set up, and trying to rear the flies on days when it's cold in the building can be a bit of a pain. In that we set flies up, and in the spring semester, early spring, the temperature in the building might be around the mid upper 60s, which is rather comfortable for us, but it's a little chilly for the flies, and it takes them a while. So we have to consider this as part of our calculation of the time at which the eggs have been deposited. Now, upon arriving at the crime scene, if you watch Bones, we have Jack Hodgins there in his jumpsuit, going to be plucking up little larvae. One of the things you do is you take all the larvae, you make note of where they were found in the area, put them into some kind of preservative. The paper we're looking at is talking about something called KAA, which is a mix of kerosene and acetic acid and ethyl alcohol, rather nasty stuff, and that's going to kill everybody. I generally just use ethyl alcohol to be done with it, but you can preserve the flies or the maggots in alcohol for years and years. So you can have the flies at the moment preserved, and that allows for microscopic analysis of what instar. And because if you remember from our discussion last week, trying to identify the specific instar is not trivial because the maggots, as they develop, are going to increase in size, and then they go through a maggot or larval molt. But the differences between the first instar and the second instar can be rather subtle. Mouth part differences, bristle differences, and so you need to have them fixed in time, killed and preserved, so that you can go back to the lab and look at them with a microscope, and then you're going to have to actually have them preserved, so when the defense attorneys bring in their experts, you can provide them with all your information. The paper talks a little bit about something called a maggot motel, which is essentially a place where you can allow the maggots to continue developing, and that way they can hatch out, and from there you have them all sitting on a little piece of liver to eat on. When they are eclosed after metamorphosis, you can then actually look at the flies and have a better determination of the fly species. Trying to determine species by looking at the maggot could be really, really hard. Much easier to look at the adult fly. And it's a way of just double checking all your bits and pieces of information. So if you join me in the paper here. We're looking at the degree day and accumulated degree day formula. So you have a couple of things that we have, like this lower limit threshold that is required because we have to decide that there is a temperature limit below which growth and development is not going to happen. And so it is essentially a pause. If it's really cold, like wintertime, there's not going to be a lot of maggot activity. Sorry, or good, depending on what side of the case you're on. If you want to drop a body in wintertime, it's going to be a little bit harder for forensic investigators to determine time of death. Body temperature is going to change very rapidly. There's not going to be a lot of insect decay. There won't be a whole lot of bacterial decay. So it's going to be a well-preserved body. In North Dakota, where I used to work, the winters would start starting around October or so. It's going to get below freezing, and it probably won't get above freezing until sometime in March. And there actually was a case that I was around for where a student was coming home from some party and ended up, as it turned out, crawling into the back of a van and died there. And it was back in November when he disappeared, and he wasn't discovered until sometime in March, early April. Yow. So that is just one of the conditions that you might find yourself. In this case, though, we've got a reasonably warm period of time when Candy Roberts was killed. The remains have been found in July 28th. So let's just go ahead and get to the actual investigation report. So, Candy Roberts, Goodtown, Indiana, Wonder County. I'm not sure if that's real or not. The remains were found on July 28th at 3 p.m. The autopsy was conducted on July 29th. So, we've got a timeline of incidents that has been backtracked from Ms. Roberts' activities. On the 19th, she had a date with one Jerry Higgins, went to a movie. On the 20th at 10:15 p.m., friends went to a bar with Candy, and she stayed with some guys who were trying to sell the girls some meth. Not the nicest guys around, but there you go. The other two girls left the bar about 1:30 a.m. All right, so now the 2 days later, depending on how you want to lay it out, the July 23rd, her friend Kelly hadn't heard from Candy, called her cell phone, received no answer, so we began to get a little bit worried. On the 24th, Candy's roommate hasn't seen her since she left with the two girls to go to the bar on the night of the 23rd. The roommate called the police and reported her missing. All right. So on the 28th, her body was found in a wooded area, Randall's Woods, lying on her right side with 3 gunshot wounds to the side of her head. Yow. Decomposition is extensive. Her head mostly skeletonized and large maggot mass moving into the upper torso of her body. No other wounds seen at this time. Cause of death is pretty obvious. Insect collections have been made before the body recovery at the scene, before the body was moved from the scene. The maggots were beginning to leave the remains and wander into the surrounding forest, leaf litter, and underbrush. They were found about 8 to 10 feet from the remains in a southwesterly direction, so that means it's been a while, and they're actually starting to move out and getting ready to pupate. Milton Henry says that he and Candy talked briefly about the money she owed him when he saw her at the park on July 25th. So we've got some interesting timelines going on here. Let's see. Okay, so here is the chart that you were given, and it's sideways. Is there a way to unsideways it? No. If I open it with Google Docs, let's see what happens. Anyway, this is a sheet. And this has got a way of sort of systematically setting up a chart for this analysis. Come on, Google Docs. Oh well. Is it just that slow in loading it in? Oh, phooey. Okay. So, thank you for your patience. And let's see what we can do from here. My Google Docs isn't working. All right, hold on a second. So, looking at sideways, what you have then is the weather station report. And sorry, you can pull this up yourself. Beep. We have the weather station report that is providing the maximum temperature, minimum temperature, and then what you do is determine the daily, the average temperature, the max and min, and then you can do the degree day with base 10 lower limit threshold, and then the accumulated degree day with base 10 lower limit threshold, and the formula for that is on page 26. So you calculate that up, and this is the filled out chart. So as I promised, I'll post this and you can kind of look at the record there and see what they got. This is dumb that I can't flip this sideways and
click and rotate.
Is there a way to rotate it? No, there's not. Not in this. All right. This is actually the data here that is more useful to us. So here are the adjusted times and the different species, and this is their development at these different temperatures. So constant temperature reading of 26.7 degrees, and then we adjust with the different degree hours. So we've got a few different species, and they have slightly different developmental times. All right, so this is the next sheet, kind of the answers that I'll hand you, and see if you can't come up with some of this information. And if you are getting too confused, we can go over it a little bit more. But the idea is that sample 1 is a larva from the head scene, and it's a mature third stage larva of Lucilia, and a third stage larva from Formia. Then we have sample 2, and these are the confirmation of the types of insects that we were finding. Sample 3 was another Lucilia, and sample 4, 5 feet from the head, yet another Lucilia. So here is the conclusions. And what you're going to do is think about the largest larvae that you find, because that will represent the oldest larvae. And you can determine the oldest larvae and then identify the species, and from there we are going to base this on the time and growth development tables provided for that species. And so we've got the various tables that have been provided to us, and the average degree day with the offset of 10 degrees value is provided. So what we can do is look at the table and see that it takes approximately 62 average degree days to reach into the distribution of what we're seeing. If we see a mature third star larvae, then we have passed beyond this, and it requires actually more degree days to generate that. So we do see mature third star larvae, and then there are other larvae that would be even older than the mature thirds. So what this allows us to do is to provide sort of an outer value, or what is the longest time that we can calculate possible based on the temperature. So with that, we would then start with that and begin looking at a minimum time of death. And so we can begin to actually establish a range. And we're looking for values between 100 average degree days and 125 average degree days. And that range is going to be achieved between the 23rd and the 21st. So that's midnight to midnight, and we know then that the flies aren't going to be laying their eggs in darkness. So we can go back to the daylight hours, that being the 22nd, but we know that she was last seen alive on the 20th. So there's also darkness period there. That is, she started out, the last time she was seen was nighttime. And that means that any insect colonization is going to have started sunrise 21st. So from this, we have a time of death that would be between the sunrise of the 21st and no later than the sunset of the 22nd. So this is the kind of information, and a fairly narrow range, that we can develop using larval size and larval distribution. A couple of variable factors is different kinds of, how much heat was there, the microclimate, radiation, that is, was it in the shade or not, being near streams, bodies of water that might change the temperatures a little bit, and these have to be taken into account. And it is part of what the experience of a forensic entomological investigator is able to bring. It's also some of the evidence that can be contested by different experts and things. So the person who said that they talked with her on the 26th, they're either mistaken or they are lying. And so that is going to provide us an interesting place to start. All right, so I'm going to post the degree day chart. See if you can find some information on that that'll match up. So the bottom line is that we know she was out with friends on 7/20/04. We have somebody that says that a friend talked with her on 7/25. The body's found on 7/28. That friend having talked with her, I'd say we need to talk to that person a little bit more carefully. Maybe bring them in. All right. Booth and Bones will be out there to ask them in for questioning. All right, so I'll post a few more bits to you. See what you can make of this, and we'll see how we can begin using this kind of information to actually narrow down time of death. That's all I know. Next week we'll start talking about some different aspects of the forensic toolkit, things like fingerprints, and then actually get into some DNA and spend some time there, because that's actually a really interesting area to work on. We're putting together some ways that we can actually do DNA testing of individuals, and so we'll see how that goes. We'll be in touch. I will talk with you guys later. I'm out.